Assalamu alaikum, my name is Ahmed Islam, Group 1, Section 14, Digital System.
My name is Tenka On from Section 14, Group 1.
Hello, my name is Ismail Mubarak, Section 13, and I am from Group 1.
For design, we are Group 1, so we take DN. So for the milli machine, we need only 5 state. As we know, the milli machine, the output depend on the current input and the current state, but for the Moore machine, it only depend on the current state. So we can see here for the Moore machine, it have one state more than the milli machine. For the milli machine, it need only 5 state, but for Moore the machine, it needs 6 state, and we added another state for to check is it done or not from the Night Rider. So this is our 7 state. So we can go to quartz. So it's the same our design from the paperwork. So we can see here. So this is our input, the clock, the receipt, and the DN our input, and the done. This will be the input comes from the Night Rider. Next will be the output, the all state here, and the enable. This will send the signal to the Night Rider to start working, and the states here, all the states. Also our transition, all the transition, and the action here. The enable will take a signal from the last state. So we can check here from the state 1. If we get the first D, it will go to state 2. If we get another D, it will go to state 3. Otherwise, it will go back to state 1. Also for state 3, if we get D, it will go to state 4. Also, if we get D, it will go to state 5. Otherwise, for the first 3 states, state 2 and state 3 and state 4, if it get anything other D, it will go to state 1 as the default state. So after we get to state 5, we need another N to complete our cycle. So if we get N, it will go to state 7. If we get D, it will stay at state 5 and repeat until get N to go to state 7. After get to state 7, this is the state where we can check if the signal comes from the Night Rider or not. So while done equals 0, it will stay at state 7, sending signal to the Night Rider to complete its cycle. When receive 1 from the Night Rider, it will go to state 6. State 6, if read N, it will go to state 1. If read D, it will go to state 2. So we can check here. So all is working, so we can go to our waveform. So this is all input and output from our waveform. Function simulation. So this is our waveform. We can see here the clock we set and the receipt. First start with the receipt, the done 4D, 1, 2, 3, 4, and 1 N here. The fifth will be N. And done here to stop the signal comes from the Night Rider to stop sending enable to the Night Rider. This is our enable, our N enable. You can drag it down. So our state 1, while read the first D, it go to default is state 1. When read D, it will go to state 2. When read another D here, it will go to state 3. State 4, state 5, until it read the N here, so it will goes to state 7. So while it stay in state 7 and no done here, no signal from the Night Rider, so it will repeat staying at the S7, and at the same time it's sending enable to the Night Rider. After it get done from the Night Rider, so it will send stop S7, state 7, and go to state 6. So the next cycle will go to state 1 again. Here, state 1 again. So that's all, and thank you.
Hello, in this section 4.4, we are required to design one hot encoding using schematic editor. So basing on this state diagram, we made the state table as you see here in this picture, and then we construct from this table the next state equations, which is three equations, and then we construct the output equations. Based on this equation, we are we have designed the schematic diagram, which is contains three flip-flops, and basing on the schematic we have put the inputs based on the next states, I mean the next state equations here, and here is the output basing on the output equation. So to make sure that this schematic diagram is correct, we compile it, and you see it has no, any errors or not. So waiting for our compilation report to be completed, and then we will have a complete report for our schematic diagram. Well, this is the compilation report. So after we compile it, we'll see the simulation result of it. So this is the waveform. We'll run functional simulation to see what's the result of this waveform. So we are all done as we have the result, the simulation result for our schematic diagram.
Okay, my name is Tenka On from Group 1. Part I will present is Milestone 4.5. Okay, this is the mini step diagram: S0, S1, S2, S3, S4. Our sequence is D, 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 N. Okay, with D, first D, second D, D, fourth D. If the feed input still D, and the step will keep remain at step 4. If the feed input is N, then the step will come to S0, and the output become 1. Okay. This is my schematic circuit. It's come from here. Okay, this is my step table. Using step table, I found the step equation, and I draw the circuit using the step equation. Okay. This is my waveform for this circuit. Okay, this is the output. Okay. Because our sequence is D, 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 N. Okay. Here we set clock D. Okay, we see D. For output here, become 1 because of here. D, 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 ready for D, but still keep putting D, 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 and the N become 1 and output on. Okay, this is our project. Thank you.